Hey friends, welcome to the YouTube channel all about electronics. So in this question, we have been given the op-amp based circuit, and in this circuit, this exponentially decaying signal is applied as an input. So here, we have been asked to find the output voltage of the circuit for t greater than 0. So here, since the input is the exponentially decaying signal, so it is better to do the circuit analysis of the given circuit using the Laplace transform. So first of all, let us find the equivalent S-domain circuit for the given circuit. Now here if you see, then the op-amp is used with the negative feedback. That means here, the op-amp is used in the linear region. And since it is used in the linear region, so there will be a linear relationship between the output and the input. And that is why, whenever we do the Laplace transform of the given circuit, then in the equivalent S-domain, the op-amp will remain as it is. Now apart from the op-amp, in the equivalent S-domain, the resistors will remain as it is. And similarly, we see the capacitor, then in the equivalent S-domain, that corresponds to 1 divided by Cs. Because here we are assuming that the initial conditions of the circuit are 0. And here the value of C is equal to 50 microfarad. So we can say that that is equal to 1 divided by 50 times 10 to the power minus 6 times S. Or we can say that that is equivalent to 20,000 divided by S. So that is the equivalent representation for the capacitor. And similarly, if we see the input voltage V in T, then that is equal to 3 times e to the power minus 5t times u of t. So in the equivalent S domain, that corresponds to 3 divided by S plus 5. So in this way, we got the equivalent S domain representation for the each circuit element. And now, if we see the equivalent S domain circuit, then this is how it will look like. So for the given circuit, now let us do the circuit analysis in the S domain and let us find the output voltage V of S in the S domain. And then using the inverse Laplace transform, we can easily find the equivalent time domain expression. So here, let's say the voltage at this node is equal to Vx. And as you can see, here the op-amp is used with the negative feedback. That means here, we can apply the concept of the virtual ground. That means here, this V plus is same as the V minus. That means here, the voltage at the inverting and the non-inverting terminal of the op-amp will remain same. So here as you can see, this V plus is equal to 0. So we can say that here the V minus will also remain 0. Or equivalently we can say that this Vx is also equal to 0. So now let us apply the KCL at this node. So if we apply the KCL at this node, then the summation of all the incoming current should be equal to 0. So we can say that that is equal to 3 divided by S plus 5 divided by 20 kilo ohm, that is this current, plus V out divided by this 20,000 S, that is this current, plus V out divided by 10,000, that is this current, should be equal to 0. Or further we can write it as 3 divided by this 20,000 times S plus 5 plus S times V out divided by 20,000 plus V out divided by 10,000, and that is equal to 0. So now if we multiply both sides by the 20,000, then further we can write it as this 3 divided by S plus 5 plus S times V out plus 2 times V out, that is equal to 0. Or further we can write it as this S times V out plus 2 times V out, that is equal to minus 3 divided by S plus 5. So we can say that this V out is equal to minus 3 divided by this S plus 5 times S plus 2. So in this way, we got the expression of the output voltage in the S domain. So now, to find the inverse Laplace transform, let us use the partial fraction expansion method. So using the partial fraction expansion, let's say it is equivalent to A divided by S plus 2 plus B divided by S plus 5. So now, we just need to find this coefficients A and the B. So for finding the coefficient A, what we will do? We will multiply the left hand side by the S plus 2 and we will evaluate the value of the expression at S is equal to minus 2. So now this S plus 2 in the numerator and the denominator will get cancelled out. And if you put the value of s is equal to minus 2, then the value of a will come out as minus 1. Similarly, for finding the coefficient b, what we will do? We will multiply the left hand side by the s plus 5 and we will evaluate the value of the expression at s is equal to minus 5. So once again, this s plus 5 in the numerator and the denominator will get cancelled out. And in this expression, if we put the value of s is equal to minus 5, then the value of b will come out as 1. So in this way, the value of a is equal to minus 1 while the value of b is equal to plus 1. So in the above expression, if we put the value of a and b, then the expression of this v out of s is equal to minus 1 divided by s plus 2 plus 1 divided by s plus 5. And as you can see, now we can easily find the inverse Laplace transform of the given expression. So if we take the inverse Laplace transform, then the first term is equal to e to the power minus 2t times u of t. Likewise, the second term corresponds to e to the power minus 5t times u of t. So we can say that the expression of the output voltage in the time domain is equal to e to the power minus 5t minus e to the power minus 2t times u of t. So we can say that for the given circuit, the output voltage V out can be given by this expression. And therefore, for the given question, this D is the correct answer.